Okay, right. Okay, dah start record. Okay, jadi saya punya interface adalah interface di dalam MacBook. Tetapi saya rasa di dalam Windows pun have the same interface. So kalau nak open, kita boleh open file tu. So file tu saya the network traffic here. So saya open. So once open, saya akan dapat all this packet dengan color-color. So mungkin kita wonder apa color ni kan. So sebenarnya dia ada color code dia. Sebenarnya kita boleh tukar color code dia based on kita punya apa dia. Kejap ya. Fahal. Kita tak boleh nak pergi ke atas ni. Dia lari pula. Dia lari-lari. Okey, cuba. Dia tak boleh buat full screen, dia jadi alright. So jadi kalau kita nak tengok di color ni apa maksud dia, sebenarnya dan kita boleh set sendiri color tu ikut color kita nak. Tapi nak setting color dia kat sini. View okay. Coloring rules. Coloring rules. Kalau dia color dia warna hitam, bermaksud paket tu ada error. Kalau hitam ni paket tu ada error. So this inilah yang menunjukkan bahawa ada error. So ISMP error, state change. So yang ni kita kena tengok. Kalau kita tengok warna hitam, ada error lah, something wrong. Hitam sama. Kalau merah, merah ni dia macam ada request sama ada kita tidak expect ada paket datang, tapi kita terima dia paket contoh. Ataupun paket tu tak ada, dia bukan nak kata error, dia ada reset punya request abort. So benda macam itulah. Tetapi yang ini juga mungkin nanti in detail tu baru kita nampak apa puncanya. Tetapi kadang-kadang kita boleh just ignore lah that color. Tapi kalau kita nak tukar that color pun okey, kita boleh tukar kat sini. Dia punya rules. Okay. So that's. Kemudian dari segi view, so you boleh tukar view ni. View ni kita boleh tukar. Kalau if you wanted to get more detail, mungkin kita boleh cuba tengok packet detail. Kita akan dapat di bawah ni ada packet detail. Boleh kita klik dekat here. So you have the packet details. You have a packet detail on what are the frame number in the frame, apa dia punya encapsulation and detail file. So in order to understand this, you need to know some of the network punya parameters. You need to understand the network terminology and also in order to dig down. Tetapi bila kita nak buat analysis, this information also important because we need also to look into this detail later. So this is the protocol. So in detail of the protocol and so on. And then dia punya IP address and also source and destination. And then on the TCP control protocol. So sometimes here kalau ada session and also kalau ada key exchange, so kita dalam paket tu kita boleh tengok dekat sini juga. So that's the segi interface. Kemudian saya nak tengok, kalau you nak tengok dari segi packet byte, dia punya value in byte pun boleh. So you boleh dapat what are the byte, because all dalam digital communication, the data is sent in 1010, right? And then the combination of 1010 is represent dalam hex, dalam hexadecimal. So it's the representation dalam hexadecimal. And also ini dia punya nama packet. So kadang-kadang kita nampaklah perkataan-perkataan yang bila dihantar dalam plain text, you will see it. Alright. So bermaksud satu paket ni, dipanggil satu frame ni adalah satu paket internet. Maksudnya dia akan send dalam satu ni. Bila kita komunikasi, dia akan hantar in one ni. So di Wireshark akan capture this sebagai satu paket. Okay. Sekarang ni, jadi kita tak tahu nak buat apa. So first thing, tak tahu nak buat apa, kita tengok dulu on the analysis, statistik. So di dalam tools dia, Wireshark ni is actually tools yang dah quite popular, being established masa saya buat PhD in 2003, 20 tahun yang dulu pun, Wireshark is already existed quite some time already. Then still today, people, security professionals still using Wireshark in order to do the network data analysis. So jadi first thing kita pakai di statistik. So dalam statistik ni dia ada banyak informasi ya. So, jadi kita tak payah go through semua. Tapi yang first thing kita nak tengok some properties of the file. First, the property of the file. Got properties. So this is the property in general. Ini dia punya hash. Kenapa ada hash ni? Because of bila kita nak compare. Sebab tu bila kita ambil di data kalau ikut properly, so kita kena kira the hash of that packet, so that bila kita send that data, kita bagi yang hash yang kita send, bila dia buka check, dia kena sama dengan hash yang kat sini. Kalau dia berlainan, bermaksud the content of that file has been edited ataupun being forged. So ini important untuk evidence validation. Dia format dia adalah format Wireshark, TCP DAM, PCAP file. Encapsulation internet. So ini tak apa. So packet, the start packet tu mula-mula counting is at 11/4/2019 sehingga inilah pukul 5 lebih. Elapsed time dia 1 jam. Maksudnya the packet capture is for 1 hour. Hardware unknown, OS unknown, application unknown. So this is the detail of the packet capture. Alright. Jadi tak ada apa-apa lagi yang kita dapat ni. So mungkin the first thing kita kena tengok is on the here kan dia ada number time ni kan. So kita boleh tengok sebelum tu kita kena tengok, tadi saya nak tengok packet capture. So kita tengok on the measurement. Betul. So packet capture properties. Kemudian dia ada statistik kat bawah ni. So kat bawah ni dia bagi time and then dia bagi statistik. What are the measurement? So packet yang captured ada 4003 packet captured dalam masa 3821.561 second, which is this one, elapsed time 1 jam lebih. Average packet per second is about 1 packet per second. Average packet size is 597 byte. Oh sorry, byte. Dan dia punya byte is total byte is 2390126. Average byte per second is 323, and then average bits per second is 5300 bits. So this some of details. Jadi yang kita dapat from here adalah jumlah packet. So satu informasi kita dapat jumlah paket ada 4,003 paket. Okay, sekarang ni tapi kita tak dapat apa. Still we did not know, we did not get any other information yet. So we need to go further. And then here is the time kan. So time ni you boleh tukar untuk memudahkan you punya analysis. Maybe kita tukarkan mengikut view time dia mengikut time zone. So okay, kita letak time. Ini dia punya time now is the second since 1970, 1970. Di dalam all the computer punya network punya devices, bila dia lock, dia punya timestamp is based on 1970 punya time. So dia kira 1 second from that. So this the time is 1 second from that time lah. Jadi kalau kita nak convert, kita kena convertkan dia, katakan kita pakai UTC. Ambil this code. Okay, saya ambil this. Saya tukar dia date dia jadi ni lah. Date apa nama? 10/4. Yang dia ni UTC punya time. Yang tadi bila kita tengok tadi dekat packet capture tu, itu bukan UTC punya date lah. Sebab tu dia punya dia ada berbeza. Itu yang itu adalah local date. Okay. So kita dapat date ni. Kemudian jadi kita still tak dapat apa-apa lagi. Kita boleh dapat date, tahu pukul berapa, sejam saja. Kemudian jadi tadi kita nak tahu apakah dia ada berapa host, ada berapa komputer, dan siapa yang paling aktif di dalam this capture ni. So, kita nak cari host yang aktif, kita pergi dekat statistik, we go to statistik and go for endpoint. So endpoint, so you got the statistic here. So meaning that we have yeah. So this address dia punya, kalau kita ini dalam internet. Internet ni adalah this is the MAC IP address, MAC address. If you go to IPv4, so you give the network address, the IP address of the komunikasi. If you add the MAC address, so the host that the most active is host with MAC address 000802.1C47EA. So meaning that, okay, based on others it's not active. So we can drill down from here. So we can say that, okay, this one is maybe potential that we investigate further, so that apa nama, we can okay, saya tak select apa lagi. Saya actually can filter from that, but before that kita go through then. So kita dah tahu that the host. So that point that we need to ni, you can jot down you can copy the address and then we use that to filter it later. Okay, now we know that there are one host that have active. So from that internet address, we filter we need to filter so that we can identify what are the packet that is being transmitted. You can go here, endpoint. Okay, go here. Apply as filter. Okay. Kita copy. Okay, saya nak guna filter kat atas ni. We'll use the filter over here. So the filter is since MAC address, kita nak filter the packet menggunakan MAC address. So MAC address is actually a Ethernet punya address. Punya the code is ETH dot address ADR. So you put the MAC address that you wanted to filter. So meaning that why we didn't take the IP address, because people can spoof the IP address, but not the MAC address. Meaning that if you put the MAC address, so you can ensure that the only one network device that are using that device, that address. So the address is 00 08 then 02 1C 47 AE. So meaning that, and then we enter. So now, actually, we got all the communication of this host. So we have this list, meaning that all the communication is from you can see that the protocol and then the timing is here. So this is all the communication of that, but still we do not know actually where to go. So we need to look into more details. So from here, already filtered. Okay, then from there, maybe kita kena we look into one of the packet and see what are the details. So we can look into the Ethernet. So actually the IP address, sorry, the MAC address is this MAC address, as I see in detail. So this MAC address or the network device has this MAC address, and the manufacturer of the IP address is a Hewlett Packard network address, Hewlett Packard, and that is the MAC address. So now you know that the machine that communicate a lot, and also we suspected have some issues, is the host with the MAC address 000802.1C47AE, which belongs to Hewlett Packard network address. Ini nanti bila the IT team kalau nak verify, so they can verify physically this ni lah,